This is Dr. James Benjamin. I thought I'd go ahead and do a version of the data set that we went through Monday afternoon. This is a two independent variable factorial analysis of variance with two levels in each factor. So we would call this a 2x2 analysis of variance, or 2x2 ANOVA. You'll notice in this case, the scenario is fairly straightforward. Let's imagine Sanchez and Smith, 2014, decide that before introducing a love potion into the general public in the middle of flu season, that they actually test to make sure that the love potion does not interact with the flu virus. So to do that, what they would do is, say, take a set of 20 mice, or 12 mice in this case, and expose some of them to the randomly assign some of them to be exposed to the flu, some to not be exposed to the flu, and some to be exposed to the love potion, and others not to be exposed to the love potion. And so what is measured is the level of Cronenberg that we see in the mice. Okay, so the amount of damage done to them externally to make them totally monstrous. All right, and you can see what the data look like, and it becomes pretty obvious that if you're both exposed to the potion and to the flu virus, you're probably going to be Cronenberged. But, it's one thing to say, hey, I've eyeballed it and it looks pretty good. It's quite another thing to have to say, maybe we need to take a second look. And so what I'm going to do is I'm going to do what I've done before. I'm going to go to ANOVA. And this time, I'm going to choose potion and flu as my fixed factors. I'm going to choose Cronenberg as my dependent variable. I'm going to go ahead and do an effect size test here. It really won't do much good. Not much I can do with the model. It's already pretty well set up, as well as you'd want it to be set up. So we won't have to worry about that too much. I'm going to kind of skip assumption checks this time around. There's no contrast we need to do. We don't really need to mess much with the post-hoc test, because we only have really two levels of each of the factors. And then, of course, something else I'm going to want to get estimated marginal means. And I'll want to get the not only the plots, because they look kind of interesting, but also the tables. And so what I'm going to do is, again, I'm going to go ahead and highlight both my factors, my independent variables, and put them in term one. Okay, and what you can see is that you get, when you look at this, the residuals look the way you would expect. The total degrees of freedom, of course, will be 11, because there are 12 individuals, but those degrees of freedom get partitioned. 1 degree of freedom goes to potion, because there's 2 levels in potion. So k minus 1, 2 minus 1 equals 1. Flu, same thing. The degrees of freedom for potion by flu is multiplicative, so it's going to remain 1. And then that just leaves us with the 8 remaining degrees of freedom for the error term. Okay, the sums of squares get partitioned the way they're supposed to be partitioned, and then they're divided by their respective degrees of freedom. These F values look ridiculously large. It's pretty clear that some serious Cronenberging has happened. Okay, and of course, once we have two significant main effects, but once we have a significant interaction, then we can do something else, which is mainly to focus our attention on the interaction per se and begin to characterize that interaction. Okay, so one way you know that you're dealing with an interaction is if when you try to plot out the marginal means plots for your two independent variables, they're not parallel. If there were no interaction, these lines would be parallel lines, but you can clearly see they are not. The other thing that you will note, so that's one thing to make note of right there. So that tells you you've got an interaction. These lines are non-parallel, and in this case, very noticeably so. You can see the mean is effectively 0 for not exposed. Don't worry about the gobbledygook that just happens sometimes. For those in the not exposed to flu, not exposed to the potion. A little bit of Cronenberging happens when people are exposed to the potion. A little bit seems to happen when people are exposed to the flu only. But as you can see, a high rate of Cronenberg happens when individuals are exposed to both the flu virus and the love potion, meaning that if Valentine's Day dances are happening during the height of flu season, you do not want to be applying this potion within the general public. Next thing you know, you will have Cronenberged your planet on your dimension, and moving into a new dimension is a real pain, as Sanchez and Smith will attest. So that is essentially it. So the main things you want to look at are to make sure that you have those descriptive statistics, and those end up being very helpful. You have your plot here that gives people a visual as to what's going on, and you actually have your ANOVA summary table that looks like a normal ANOVA summary table that you would see in your textbook. Alrighty. I will leave you with that, and all you have to do is remember, save your results, and once you've saved, then go ahead and upload that to the appropriate assignment, and you will be done. Alrighty, until next time, see you later, and go with science.